Statistics is about extracting patterns from data, and in this tutorial we'll have a brief discussion about the nature of data. We will introduce some definitions, but more importantly we'll spend some time discussing various measurement scales associated with data, because as you will find, not all data are created equal, and the measurement scale has an impact on the kinds of analysis that you can do with the data. So this worksheet or this table is what I will be using to introduce those concepts. Now this table has a very regular structure, very well-defined structure, meaning you can see it consists of rows and columns, and a lot of business data is organized and collected in tabular format. If you think of business transactions, information about products, about customers, sales, and so forth, they all tend to be organized and collected in this tabular format, which is why we will be focusing on this particular organization of data in this course. But just in passing or as an aside, I should point out that a fair amount of business data, particularly these days, is very unstructured. If you think about various social media platforms, where you have information possibly about customers and products, either in text form, in image, video, audio. So those are unstructured data and they need to be analyzed differently from what we're doing here. But in this course, all the data that we will be looking at and analyzing will have this nice regular tabular format, because a lot of business data is organized this way. So with that said, let's start off at the very highest level. The entire collection of data that you're going to be analyzing, in this case this entire table here, the entire collection of rows and columns, is what's called a data set. So that's the largest level of aggregation. So we have data set. So in this case you can see our table, our data set consists of information about various countries. So we might call this a country data set. If you were with the Motor Vehicles Bureau, you might have a data set about drivers. If you were with the IRS, you may have a data set on taxpayers. Okay. So now if we drill down one level, what does this data set consist of? This consists of rows and it consists of columns. Okay. Now let me focus on any one particular row. Now, let me pick Belgium here and I will highlight it with the particular color. So this particular row, any one row, is referred to as an observation. So a data set consists of many different observations. In our case, our data set consists of, let me see, 60 countries or 60 observations. So these observations are also sometimes called elements. Why? Because each observation consists of data recorded about a certain element, each element in this case being a country. So row, observation, element, these terms are synonymous. Now if you go across the row and look at the columns, these different columns are the attributes of the elements that are being stored. So for each country, we are recording what is its WTO status, what is its per capita GDP, and so forth, all the way up to what is its average yearly temperature. So the columns are simply the properties of each of these elements that are stored, and it is your design decision as to what properties you want to store. So you could think of many different properties of a customer. That would be the attributes of a customer data set. So which particular attributes are recorded, that's a design decision that has to be made at the time you do your data collection and setting up your data set. So columns are the properties, and the other two terms that are used to refer to columns are also variables and attributes. So these are synonymous. Rows, observation, elements, these are synonymous. Columns, variables, attributes are synonymous. So pick red. So here we have divided off a data set into rows and columns, and those are your the synonyms for rows and columns. Now, we are going to concentrate, as I said, we're going to spend most of our time discussing measurement scales, and for that we need to concentrate on variables, because if you look at the columns, this is where the data actually gets recorded, the properties of each of these elements. So let's focus on variables. And we're talking about measurement now. Now, variables come in two broad flavors. They can be qualitative or they can be quantitative. Okay, so let's look at the two qualitative variables. Here's one, WTO status. Let me color it in some particular color here. WTO status, and another one is Fitch rating. So a Fitch rating is a credit rating for the company, similar to your Standard & Poor's or Moody's. So in both cases, you can see the qualitative variables, generally speaking, are not numeric. They are alphanumeric in nature, and they tend to be just labels attached to this particular any particular element, any particular observation. So they tend to be alphanumeric. Whereas by contrast, if you look at quantitative variables, here's one, per capita GDP. I will give it a different color here. Excuse me, per capita GDP, and then the average temperature. These are two quantitative variables, and you can see that they're numeric. Okay, so quantitative variables have to be numeric, but not all numeric variables are quantitative. And that's fairly easy to see. Suppose you had a student data set, and one of the columns or one of the attributes is the two students' social security number. Now, the social security number is clearly numeric, but it is not quantitative. You cannot subtract. It's not meaningful to subtract two social security numbers or take the average. Similarly, the zip code of the student's address, that's numeric, but that's not quantitative. You can't do any arithmetic with it. So what makes a variable quantitative? It's not the fact that it's numeric, it's the fact that it measures some kind of magnitude. A quantitative variable has to be measuring the magnitude of something, and that's why it ends up being numeric, and all quantitative variables have to be numeric. But some numeric variables don't, such as telephone numbers, don't measure any kind of magnitude, hence they are not quantitative. So remember, it is not being numeric that makes a variable quantitative, but rather whether it is measuring some kind of magnitude. Okay, now that we have distinguished between qualitative and quantitative variables, we want to make slightly finer distinctions here. So even within qualitative variables, there are two different types of qualitative variables. So once again, let's look at WTO status and Fitch rating. Those are the two qualitative variables we pointed out. Now, if you look at the values of WTO status, one value is member and the other value is observer. So a country could be a member of the WTO or it could have observer status. Now, if you look at those two values, member and observer, they're just labels. They tell you whether or not a country is a member of the WTO. However, the Fitch rating, even though it's qualitative, it's not numeric, there's a certain order to it. I think you will agree that a Fitch rating of A+ is better or higher than a Fitch rating of B+. Similarly, a Fitch rating of AAA is better than this BBB-. Okay, so in Fitch rating, even though the values are qualitative, there is a certain order to them. So that kind of a qualitative variable is called an ordinal. So a qualitative variable can be ordinal, whereas WTO status, it's what's called a nominal qualitative variable. It's just a name, it's just a label. So another example, in a customer data set, if you have gender of the customer, the gender, so you would have a column called gender and the values would be male or female, and clearly there is no order to male or female, it's just a label describing a property of the customer. Whereas if you think of the credit rating of the customer, good, fair, bad, that's qualitative again, but it has a certain order to it. Similarly, if you have a student's letter grade, it's qualitative, but it has the values A, B, C, and so forth have a certain order to them. So qualitative variables come in two flavors, nominal or ordinal. You have a similar situation with quantitative variables. They come in two shades. Okay, so here again, let's look at per capita GDP and average temperature. Now I'm going to pick two values over here, 5,400 and 10,100. Okay, let me just put so here's one and here's the other. Now they're not exactly double one another, but let's see, 10,100 divided by 5,400. Let's say it's approximately 2. So I'm taking the ratio of two values in this column. Now, with this ratio, it makes sense to say that the per capita GDP of Colombia is twice as much as the per capita GDP of Armenia. So ratios make sense and they can be interpreted accurately. Okay. Similarly, if you had a data set of students, and in one case you have a student who weighs 200 pounds and another student who weighs 100 pounds, it would be perfectly okay to say that one student is twice as heavy as the other. So ratios make sense and they can be interpreted properly. That's not the case for average temperature. So let's do the same with average temperature. Let me find two values that are roughly double of one another. So let's say Australia 21.65 and Croatia. That's, again, I'm just picking two values that are roughly twice, not exactly. So here we have 21.65 divided by 10.9. Let's say, and again, let's say that's approximately 2. Okay. However, in this case, it would not be accurate to say that Australia is twice as hot as Croatia. Why? Because even though both these two variables are quantitative, they're measuring a magnitude, the difference in these two cases is the interpretation of zero. Okay, what does zero mean for each of these two scales? So for per capita GDP, if you have a value of zero, whatever magnitude, we said that a quantitative variable is measuring some kind of magnitude. A value of zero means the absence of that magnitude. So if you have a value of 0 for per capita GDP, then that means that that country has no per capita GDP. Okay, that's absence of magnitude. And that is why this ratio of 2 makes sense. Can be interpreted as one being twice the other in magnitude. But for temperature is an indicator of the level of heat. However, in this case, a value of 0, if something or a country or any object has a temperature of 0 degrees centigrade, then it doesn't mean the absence of heat. Okay, therefore the only valid operation that you can do with average temperature, even though it's numeric, even though it's quantitative, is you can take the difference between two values. You cannot take the ratio of two values. The ratio is not meaningful, but the difference is. So I cannot say that Australia is twice as hot as Croatia, but I can say that Australia on average is 10 degrees warmer than Croatia. So the difference between the two, 21.65 minus 10.9, is meaningful. Let's say it's approximately 10 degrees. Okay, is meaningful, but the ratio is not. Okay, so there are two kinds of quantitative variables. One is ratio scale, which is your per capita GDP, and the other is what called interval scale quantitative data. Fortunately, most of the business data, quantitative data that you will be playing around with will be ratio scaled, and you can take the ratios are meaningful. Another common example of a variable that is interval scaled is dates. Okay, so if you have two dates, then it doesn't make sense to take the ratio of two values. You can't say that one date is twice as much as the other. Why? Because if you have a date is an indication of your position in time, in the scale of time. But if you have a value of 0 for a date, that doesn't mean the beginning of time. It's simply a convenient place for us to start our calendar counting. So just like in the case of temperature, a value of 0 doesn't mean the absence of heat. Similarly, in the case of dates, a value of 0 doesn't mean the beginning of time. So you can subtract two dates, but taking the ratio of two dates is not meaningful. So a date would be an interval scale value as well. Okay, so just to summarize what we have discussed about data. So we have introduced the terms data set, observation, variables. And we said that variables can be measured on two scales. Variables be either qualitative or quantitative. And even within each of those, there are slight variations. Qualitative variables can be nominal or ordinal, and quantitative variables can be ratio, scaled, or interval. And the measurement scale that is used for the variable has an impact on the kind of analysis that you can do with it. Okay, so that's takes care of our discussion of data and measurement of data, measurement scales for data.